All right, welcome to day 3, where we are going to continue our work with energy and remind ourselves of what we are doing this for, building the app for the bungee jump. So starting off, our warm-up question, again, 2 energy transformations and 2 energy transfers that you see in the image. Again, you should have completed this by now. We see a lot of different things happening. The baseball is being thrown. The bat hits it. When the bat hits the baseball, we can see that there is a lot of transfer of energy from the bat to the ball. We also can see the transformation of the color, right? That means that kinetic energy is turning into thermal energy because this is a thermal camera that we can pick up heat signatures. And so you can see that the bat and the ball both are glowing white after the impact, and that's because they're transforming some of that kinetic into thermal. Another transfer that you might notice is the ball hitting the shoe right there at the end. And again, that's converting some more of that kinetic energy into thermal because we can see the spot on his shoe light up and even more of the ball surface light up. Couple different transfers, couple different transformations. Just a quick reminder that the law of conservation, again, energy can neither be created nor destroyed. It can be transferred, it can be transformed, but not created or destroyed. So again, make sure that you know what that word or what that law is. Any of our terminology that we're going to be using for this unit, if you haven't taken notes on it, you might want to have notes for those things. Law of conservation of energy is obviously an important one. Transfer and transformation were 2 that we talked about last time. Picture example, basically that the total energy should stay the same over time, right? It might change the types of energy, but the total should stay the same. So looking at the basic physics of bungee jumping, again, we've been doing some bar charts in the last couple of days with the PhET simulation and with the different scenarios that we watched videos on. We do have a paper copy of this for you guys to go ahead and take a look at, and we're going to go ahead and look at how we would fill that in. So you can pull out your paper for that. Again, you're going to want to go ahead and pause the video here so that you guys can have a chance to fill that in, and then we'll take a look at it together in a minute. All right, hopefully people were able to pause the video. Again, I'm going to kind of talk through these. Last time, I'm pretty sure we used red for gravitational. I don't remember what color we used for kinetic energy, but we'll go ahead and start off with the gravitational. So initially, we have the person way up high, right? They have lots and lots and lots of gravitational energy. So I'm just going to go ahead and fill the gravitational up to the top. All right. I'm just going to go all the way through and do all of my gravitationals. When they're at position 2, right, they're at 3/4 of the initial height. So not all the way up, but they should be relatively close to the top for gravitational. Again, gravitational is based on their position or height. And since they are still pretty high up there, they should still have a pretty good amount. The position 3, when they still are at 1/4 of their initial height, so we're going to want to go about 1/4 of the way up. I'm just going to call it about there. Again, not worried about precise measurements or anything like that. For the final position, they are technically off the ground. They are not touching the ground. That would be bad in the case of a bungee jumper. So I do want to give them a little bit of gravitational energy. Right? We don't want to have zero here because that means that they are on the ground, and that would be no good. So we have this filled out for our gravitational energy. So we can go ahead and think about what that means for the other types of energy. All right. The next one that we're going to look at is kinetic energy. As they are at the top, just standing there, they don't have any kinetic energy. They have not started moving at all. When they are in position 2, they have started to fall. So they've started to gain some kinetic energy. Notice that the bungee is not stretched at all, right? So we haven't done anything with our elastic yet. So we're going to fill up both of those 2 boxes as kinetic energy. For position 3, right, they have stretched out that a bit. We can see how many boxes we're missing. Here, let me just fill that one in with red all the way to that line just to make it easier for calculating stuff. All right, so I've got 1, 2, 3, 4, 5 boxes that I need to fill in somewhere. And we remember that because the total energy has to be the same. We were all the way up to the top, this one all the way up to the top if we stack them together. So we still have 5 boxes to fill. Maybe I'm going to fill 3 of these with kinetic, but I still need 2 more boxes, and that's going to go into the elastic, the stretching energy. So I can go ahead and fill that in right now. All right, close enough. Doesn't have to be perfect. For position 4, right, we're all the way down at the bottom. We are fully stretched for our bungee, and we're not moving anymore. Because if we were continuing to move down, we'd be gonna, hit the ground or something. We don't want to do that. So again, I'm just gonna fill this in just so that it gets all the way to that line, just to make the next step a little bit easier. So I still need to fill in 1, 2, 3, 4, 5, 6, 7 more boxes. Basically everything except for 1, right? So I can just go all the way to the top except for 1. All right. Looks good. Again, our total energy should be these things combined. So we could go ahead and fill this in. I'm just going to put that gravitational on the bottom there. And again, that's those 2 things added together. I'm going to go ahead and fill that in for the rest of these. All right, so we filled in the rest of these. Again, pardon my atrocious drawing skills, but that's okay. Again, does not need to be perfect. Again, if we stack these together, we get total energy. The total energy should stay the same the whole time. It's always all the way to the top. All right. Clear all of that stuff. All right. Give you guys some time to write a sentence about the most important physics principle involved. I'll give you a hint. It deals with energy. And then I want a sentence or 2 talking about what's happening at each of these positions. So at position 1, what's happening in the jump, and then where the energy is, and why it makes sense that the energy is there. Again, you can look back at your pictures to help you figure some of this stuff out. But we just want kind of an overall what's happening in the jump and where the energy is. All right, so again, pause the video there so that you guys have some time to do that, and then we'll continue on with the rest. All right, continuing on. The next thing that we're going to be looking at is Extreme Bungee Adventure. This was our request for our proposal. And so what we want to do is kind of think back to what is it asking us to do? Well, it's asking us to build an app, and the app needs to calculate some things so that we know how much bungee to give the person. Now, we've got some more videos to kind of show you guys. So this is Miss Hardinge, who's just down the hall from us, and she's a physics teacher. And this is her bungee jumping this last year over the summer. That's her going down backwards. And then this is her going facing forward. And again, they need to know how much bungee, right, to give that person. They give her too much, she wouldn't be here with us to teach physics. They don't give her enough, it's not very fun, she's not going to do it again, right? So they had to calculate how much bungee do we give this person based on their height, based on their weight, based on all sorts of things, so that they know exactly what to do. And you'll notice they have a bunch of different bungees set aside for different people depending on things. All right, we've already seen this video. I'm not going to watch this one again. Obviously, you guys could flip through it if you wanted to. We are going to start taking a look at our portfolio, and starting that off, we're going to be having you guys read through that request for proposal and highlighting some important things on that portfolio. Constraints are parameters that you have to meet to solve your problem, right? The jump has to be safe. If that's not met, you did not do your job. The criteria that we're looking at is going to be things that could be done better, right? This is your area to really shine. But again, just working is going to be the constraint. Criteria is, how pretty you make it, things like that. So how user-friendly is the app? So what we're going to have you guys do is go through and highlight with different colors based on what it is. So in the classroom, you guys have the coding app for Bungee, and you can open up that engineering portfolio. And here again, the instructions are right here. So here's the app request, and you're going to need to highlight the parts in green that are important values that you guys are going to need for inputting into your app later on. So what are the things that you're going to need to know about the jumper so that you can put those into the app? In red, we're going to highlight the output that we are looking for, the overall output of the app. In purple, we're going to highlight any constraints. And again, remember that these are the parameters that you have to meet. In pink, we're going to have you guys highlight any criteria. Again, this is the sliding scale that could be variable. So read through that short paragraph and highlight as you go. Again, I'd probably read through it myself first, then go back and highlight, and then look back over it again and make sure that my highlighting was correct and that I wasn't missing any parts. All right, so again, you should pause the video here so that you guys can go ahead and fill that out before we move on to the next thing. All right, again, that's all kind of the same stuff there. After you've done that, right, we're going to be thinking about our system analysis because we've got a really complex situation and we need to be able to break it down into more manageable pieces. We're going to think about a system analysis just the way that we did for the car, right? And we broke it into more manageable pieces. This is what we're going to do again, right? We're going to need to know how to find all these things. Do we calculate it? Do we do an experiment to figure this out? Do we just measure it? All these different things we're going to need to figure out. These are all important things. So we need to try to figure out EG, right? What is EG, gravitational potential energy? What is that related to? How is that going to change based on different things that happen in our situation? So, as our inner scientists, let's kind of just think about it and see where our internal logic gets us, because oftentimes our internal logic is pretty good. What do you think has more energy, right? A physics book that is a certain height off the ground, or a physics book that is twice as high off the ground? And how much energy do we think that that would have if the one that was just h off the ground had an energy of 10? What do you think? Hopefully, you came to the conclusion that it should probably have double the energy if it's twice the height off the ground. And in that case, then yes, your internal logic is perfect, and we should expect it to have twice the energy. Another way to kind of think about that is if we were to double the mass, and we'll get to this in a minute, but if we were to double the mass of the book, what would that do? Well, it would also double the energy. And so here we get the equation that we're going to be using for gravitational potential energy. Gravitational potential energy equals mgh, where m is the mass, g is the constant. In this case, it's our constant that we would measure if we were doing a lab. And for Earth, it's 9.8 meters per second squared. That g, that is the acceleration that any object is going to feel at the surface of the Earth. So if you drop a pen, if you drop a ball, if you are falling, whatever, all those things have an acceleration towards the Earth at 9.8 meters per second squared. Every planet has its own value. The moon has its own value. Again, so those would be things that you would need to experimentally kind of figure out. And of course, h is just the height off the ground. So now we can think about a couple of different situations. We want to try to rank these. Which one do we think would have the highest? Which one do we think would have the least? And so on and so forth. So we'll go ahead and rank these from least to greatest amount of energy. Again, I'll pause it here so that you guys can go ahead and rank those, and then join us again to double check your answer. All right, hopefully you had a chance to go ahead and rank those. And of course, we want to be thinking to ourselves, okay, which one should have the least amount of energy? Well, B is directly on the ground. So if we're thinking the equation is mgh, well, we know that h is 0. So that's just going to be 0. So that's a pretty boring one. I'm going to write the equation mgh real quick up here. mgh. And again, g is about 10, so I'm just going to estimate most of these and say, okay, this one was 0, so that was our least. Then the next one, the next least, well, we're kind of thinking about A and C. A is only one book, whereas C and D are both 2 books. But C is closer to the ground, right? So we can kind of think which of these things has more of an impact. Well, let's go ahead and take a look at our equations and plug in some actual numbers here. So we said that M is 5, G is about 10, as we said, and H is about 10. But remember, for A, we have 2 of those, right? So it's really, we're looking at 5 times G, which is 10, times 20, because of course 10 plus 10 is 20 off the ground. So this one, we're looking at about 1,000 for this one. Okay, well, let's check and see what we got for C. All right, well, we've got 2 physics books, right? So for the mass there, instead of 5, we're going to put a 10 for the mass there. G is still 10, so that's not a problem. And the H is again 10. So 10 times 10 times 10, again, we have 1,000. So if your intuition was that these are about the same because one has twice the mass and one has twice the height, and therefore they should be the same, then good, perfect. If it helps you to do the math, if it helps you to just calculate stuff out, yeah, nothing wrong with that either. All right, let's go ahead and take a look at D. We're pretty sure D has the most, right? It's got double the books and double the height, so it's definitely up there. Well, its mass is 10, because again, 2 books. We also have G, which is 10, but we also have a height of 20. So when we multiply all those things, we get 2,000. Which again, you don't need to calculate it to figure this out, right? It should have double what A has because it has double the mass. Or it has double what C has because it has double the height. Same number of books, double the height. So again, our order from least to greatest should be B is the least, then A and C are tied, and then D is the greatest. All right. So gravitational potential energy, again, we have the equation energy, gravitational, is equal to mass times gravity times height. And again, I was just cheating and using 10 instead of 9.8, just for those quick back of the napkin type of calculations. We will want to use 9.8 when we're doing anything official. All right, we're going to go ahead and put that into our system analysis. So I'm going to pull up our engineering portfolio again. System analysis here, right? We have all sorts of stuff going on, and we want to put that equation somewhere. And really, it doesn't matter where we put it, but we're going to want it somewhere. And I'm just going to put it off to the side on the left here because there's a lot of space over there. So it should be so that you can just type right on top of that picture. And I'm just going to put it all the way down at the bottom, just because why not? And I'm going to put E sub G, and that's just control comma to get the subscript. M G H. And again, if we want to go ahead and put what these things are, that's probably a good plan as well. We can say like M equals mass, G equals 9.8. The value of G is more important because we're not going to be bungee jumping on another planet or anything like that. So we will always just be using 9.8 there. I don't want that to be a capital M. I don't want that to be a capital G. And it's going to do the same thing, so we don't want that. All right. So E sub G, or gravitational potential energy, the equation for that is mgh. We know the mass is m, G is 9.8 meters per second squared, and h will be the height. So we do need to know the mass. We do need to know the height that the jumper is jumping from, right? Those are going to be important things. You should also be able to fill in these bar charts, again, based on what we did in the earlier thing right here, right? We're just looking at the top position and the position 4 to put into our thing here. And again, we can just copy this whole thing because I don't think we can double click and edit. Nope. So we'll just copy this whole thing and then we can insert a drawing if I did that correctly. And paste it in. And that allows us to go ahead and color things in. If we wanted to, we could have also just done our text in here. I know that there's nothing wrong with that, right? So energy, gravitational, is equal to mgh, and so on and so forth. We could just edit it this way. We can also, we can also go ahead and fill in our energy diagrams. Again, how much gravitational, how much kinetic, color it, shape it, however you need to, and so on and so forth. And then you can save it that way. Again, I can get rid of my other one since I've done this one on top of it. All right. If you guys have finished all of this stuff, you do have probably some time to finish up what you need to for the PhET simulation from the other day. So make sure that you guys are working on that, staying productive. If you guys have any questions, if you need help with anything, as always, let me know. Double check that we've gotten all that we need to get. Yeah, awesome.